So mathematics at Elmhurst University, and a couple of things that I want to talk about is we actually have four areas that you can major in, and the first is just our straight mathematics major. Students that major in this often go on to graduate school, or they get jobs out in industry. Some of them have computer science backgrounds as well, or business backgrounds, and so we'll talk about some of the things that they do. The other one is the actuarial science major. And for those of you that are not familiar with that, these are actuaries work with insurance companies. We have several big insurance companies in the area. We have our Allstate, we have Blue Cross Blue Shield, and there's some of the smaller companies as well. And we have many former students that work at both of these places and some of the other insurance companies across the country. Then the other one that are also very popular is our secondary education and mathematics, so teaching mathematics. And what's really great about our program is that when you're done, you're actually certified to teach in both middle school and high schools. So it just leaves your options open, which is really great. If you are more interested in high school, it never hurts to still have the option of teaching in a middle school when you're job hunting, and vice versa. And then there's another major, I think it's technically housed in the education department, but of course we're very connected to it, is the middle grade mathematics major. And so these would be for students who specifically know that they want to teach middle grade mathematics. So these are some of the opportunities that you have as a mathematics major. We also have two minors that are specifically in mathematics. And so this would be perhaps if you were a computer science major, for example, you may want to minor in mathematics. And many of our computer science majors, or not many, but several do, because they are taking a lot of mathematics with the computer science major as well. And so they just tack on a few more courses and they have a minor in mathematics. Some get a dual major with mathematics. It just depends. And then there are students in other disciplines who want to teach elementary school, and they want to get a minor in mathematics education. So for anyone interested in teaching in the elementary school, and then that they want to have a focus in mathematics, they can get this elementary school math education minor. Dr. Jeffrey will talk about the opportunities from computer science. So there's someone who is a math major could easily get a minor in computer science. And we have many students that minor or dual major in computer science, business, sometimes physics. We've had students go off to medical school, so a variety of things that you can do with a math degree. Within that category of just being a mathematics major, we actually have four what we call concentrations. One is applied mathematics, one is graduate school, or I might give it the word pure mathematics versus applied mathematics. Both the applied mathematics and graduate school one, a lot of students in those concentrations do go on to graduate school. It's just kind of the focus of what type of math they're interested in. Business financial, and then we've just recently added a data science concentration, and we're looking to eventually make a data science major. So, and just a side note, we do have a graduate program in data science that Dr. Jeffrey, I don't know if he'll mention it or not in his presentation. So these are all things that lead into a variety of things that you can do with your mathematics major. And this is just in the just straight math major that we have. And then here's the big thing that's really great. What if you can't decide? What if you know you want to do math, or you want to do something along these lines, and you're not sure, you're not even sure whether you want to teach or whether you want to do actuarial, or just be a straight math major, or do something more business focused. It's okay, because all of these concentrations and all of these majors start out with the same first courses. And so you really have some time to decide. The major actually begins with our Calc 3, but we always need Calculus 1 and Calculus 2 to get in there before we get to Calc 3. And then discrete mathematics, which is a class that both our math majors and our computer science majors take, is one of their kind of first courses in the majors to prepare them for many of their later courses. So yeah, that's one of the really great things, is you don't really have to decide for sure which one you're interested in. And we've had many students switch back and forth. You know, they come in thinking they want to teach, and then they change their mind and want to do graduate school, or they change their mind and want to do actuarial, or vice versa. They come in thinking they want to be an actuarial major, and then they decide they want to do something else. So it's very easy to transition back and forth between the different concentrations, and even between the actuarial science and the mathematics major, it's very easy to transition. Lots of things that I just want to mention. We have a math club that one of our newer professors, Dr. Farnham, has really taken a hold of this year, and they meet and do some really fun and interesting things. We have students that are involved in professional societies. I just listed the Mathematical Association of America. We have the Pi Mu Epsilon Honor Society. And there are opportunities with, particularly with Pi Mu Epsilon, to present results of research that you might do here on campus. So those are some things that you might have opportunities to do, which is on the far right of this presentation. Some research, and then possibly present them at national conferences. And if travel is allowed, you can travel to these conferences. So that's something that's really great. And then we also have the Associated Colleges of the Chicago area. So that involves our college and several colleges similar to us in the area. And we have every semester, we have presentations and talks that are bringing speakers for these this consortium of colleges. And in fact, one of the speakers this past fall was a friend I went to graduate school with 20 years ago. So it was really great to see him again and see all the work that he's been really doing. And he was doing work he does a lot of work, but what his talk was on was social justice and mathematics. So that was a really interesting talk to go to. We have a seminar series in our department itself. And so we have talks every week, every semester, most of the weeks. It starts a few weeks after the semester starts. And we have faculty from on campus, both in the math department, computer science, physics. We've occasionally had the criminal justice faculty, or some of our adjunct faculty or chemistry come and speak. We have speakers that come from the regional area, or occasionally from further away. And then our students present their research in this seminar series. And then one of the other things is, of course, internships and student teaching. Like I said, we've had students do internships at places like Blue Cross Blue Shield Insurance, Allstate, American Family Insurance, I believe a student did up in Madison, Bosch. A lot of students have done some internships at small businesses in the area as well, kind of to learn about more small business, banks, Bank of America, places like that. And then, of course, our student teachers teach in a lot of the school districts here in the suburbs, as well as in the city of Chicago. And so those are all great opportunities that you're going to have in math, in computer science. Those are great things to be looking for. And then for the math department, we have all of our students do have to do a research paper their senior year. And it's a great opportunity to kind of tie in a lot of what you've learned in your mathematics over the years. And you work with a faculty advisor one-on-one, and you tend to meet weekly and update the progress. I just put a couple of titles of some of the projects that some of my students have worked on over the years right there, looking at patterns in Illinois Lotto, and a more physics one that was action potential, physics biology, action potential in neurons, and one that was kind of statistics normal distribution. So there's a variety of things that students work on in this. Let's see. Oh yeah, so this is just a list of, I have a variety of things that are alumni have done that have graduated from here. Many have gone to graduate school. They become, like I said, we've had students go on to medical school. Teachers, the two big ones in the center are the teachers and the actuaries. Those are our big ones. But people do a lot of different things. We have investment managers, consultants, they go into business, computer programmers. We've had engineers, students that go into economics and data analytics. And so there's a variety of things. And one of the students that graduated with a math and physics major here, I just like to plug this, professors, he was awarded a couple years ago, the Presidential Award for New Scientists. So it's someone who's a new professor and working on research, and it's probably one of the highest honors they can get is this Presidential Award. So just because we're a small school doesn't mean that our alumni don't go out and do amazing things. So it's something really exciting. And this is just the math faculty we have right now. Dr. Fenya is currently the chair, and then I'm Dr. Crawford. And so if anyone has any questions later on or wants to contact me, please feel free, and hopefully Kayla can provide our contact information. I'm happy to have anyone contact us if they need to and stuff. So that's just a quick little run through. Does anyone have any questions?
We will pass it on to Dr. Jeffrey to talk about Department of Computer Science and Information Systems. And if anybody thinks of any questions along the way, again, feel free to put them in the chat and we'll revisit it at the end of Dr. Jeffrey's presentation as well.
All right, I saw one of the chats was, am I going to talk about the gaming and entertainment programs? Yes, I will. So let me continue on. So thank you, everybody, for your interest in both math and computer science information system majors. And what I want to do tonight is just go ahead and talk about all the different majors and programs that we have. I'm going to focus on the traditional undergraduate majors. I'm going to try to describe them as much as I can in the limited time and then compare the differences between them and some of the related majors. We do service other departments and in the sense of providing them key courses in the core of their majors, such as digital media. And I'll talk about jobs related to the majors and what our students are doing in the recent years, in the last few years. But we have majors working in the industry for many years. I've been here for, this is my 40th year. And so I've got to see many changes over the years in this. And I'll talk about all the different opportunities and jobs today. And we have kept up with what's going on in industry. I'll also talk about extracurricular activities beyond the classroom. And then student and faculty collaboration, and then I'll take questions at the end. And again, go ahead and type in the chats if you have questions along the way. First of all, let's look at the CSIS department and related majors. At the core, we have computer science and really information systems. That's how we started, and we were part of mathematics up until 1988. And split away since then. And over the years, we've added more and more majors. And one of them that we added in around 2006, 2007 was computer gaming and entertainment technology. We abbreviate that CGE, and that's how I'll talk about it in this talk. And then cybersecurity is a recent major, although we've had courses in that within the information technology, which is starred below down here. And whoops, I keep, and that is for an adult, meaning 24 and above, and it's usually for career change, an accelerated program. I'm not going to talk about that. That's a separate entity, separate major. What I'm going to focus on is computer science, CGE, CYS, and IS. We also, as I mentioned earlier, service courses for digital media, meaning that we provide, for example, ethics in digital technology. That's a required course in there. And computer graphics and web design and development. Those majors have to create a portfolio and develop a website to display their portfolio. So they have to understand basic HTML and JavaScript and things like that. Then we also have our data science that Dr. Crawford mentioned. It's a concentration in mathematics and soon to be, hopefully soon to be a major. We have two master's programs, one in computer information technology. This is usually for people making career changes. It's not a computer science program, but it's emphasizing database and network technology for people making career changes but already have a bachelor's degree. Then we have a master's in data science and data analytics, MDS, and Dr. Crawford alluded to that, and it's completely online, and we have tremendous success. People are getting major jobs in that, and a lot of people doing very well after graduating in that. But let's look at computer science. I'm going to try to explain that it's more than just writing programs. It's the study of algorithms at its heart. It's such a wide spectrum of applications, but at the core are algorithms in every application, every domain of use. And what we do is we study the formal and mathematical properties of algorithms. We look at hardware realizations, meaning actual computers, central processing units, graphical processing units. How is memory realized? We don't build chips. We are not computer engineering. We're not at that level, but we do have to understand how computers work. And then we also look at linguistic realizations. Even within data science, you have to process and massage data and clean data. And in a way, they form many languages, and we have to understand the tools and the ways of filtering out data, for example. When you learn a programming language, that's a linguistic endeavor. We talk about grammars. And then we look at all the different applications. That's what's so exciting about computer science, is that you could work in the healthcare field, or you could work in the insurance field, or physics, or something like that, or pure computer science. There, you become an expert in that domain, but you are writing programs. You're looking at overall systems, looking at how to best use a parallel high-performance computer. It's really exciting. So career paths. What can I do with CS? Designing and implementing software is one way to do it. Devising new ways to use computers. Developing effective ways to solve computing problems. Planning and managing organizational technology infrastructure. Paths 1 and 4 are often followed by our students. Most of them go into software development, implementing software. We had students recently go to GM, and they're writing software for cars and sensors and things like that. Number 4, planning, managing organizational technology infrastructure. We have a lot of students that are overseeing, like at an insurance company. They will work with all the different vendors out there to make different third-party software talk to each other, but they have to understand programming. 2 and 3 are usually required for graduate school. We do have many students who go on to graduate school or go into industry for a while and then go to graduate school shortly thereafter, either at night or go back full-time. Just to show the wide spectrum of areas of study in computer science, I just listed all of these. I know it's a lot to read through. I don't expect you to read through all of this, but I just wanted to give you a feel for the kinds of areas that computer scientists work in. And there are some that are more interdisciplinary, like computational science, the third bullet point. That is a umbrella term. We talk about computational physics, computational biology, things like that. We are, in the next couple of years, we're talking about doing some sort of interdisciplinary work in that. I'll talk more about that later in the talk. But concurrency theory, parallel and distributed systems are big areas. Machine learning, of course, database and information retrieval are it's ubiquitous applications there. But at the core is the very first bullet point, algorithms and data structures. And in our artificial intelligence courses, we cover machine learning, we cover neural nets, one type of way of realizing machine learning, and machine intelligence, the general term for that. We have software engineering, which is different than computer science, but a lot of our curriculum does have what we would normally throw into the term software engineering, or what would be part of what we would term software engineering. But I'll talk more about that later. One of the great quotes I love is from Edgar Dijkstra. He's one of the pioneers in computer science, and I want to just say that computer science is no more about computers than astronomy is about telescopes. Basically, when you're looking at computer science, you're looking at computers as a tool, just like mathematicians and physicists and financiers and accountants use computers. They're just tools. But we just happen to be involved in the algorithms and the design of the computers and new ways of using computers. Quantum computing is a big area right now. It's a completely different way of looking at what a computation is. And then there's a question that I often get from parents and prospective students is, so why do you call yourself computer science and information systems? What's the information systems part? Well, that is a major that tends to relate more to the business and high-level view of software-based systems, that first bullet point. The second bullet point, I would just try to capture it as like being less programming and algorithm analysis and higher abstraction view of computing systems than the CS curriculum, the courses that you would take. There is an overlap, and it's not to say that information systems majors don't eventually go in to be software developers. Some do, but a lot of them go into project management and bigger picture things and being in the domain of business systems. So IS concepts are often, in the third bullet point, often applied to management of accounting, finance, healthcare, inventory control, marketing systems, just to name a few. And some students in the last bullet point focus their study on like geographic information systems, GIS systems, intelligence decision systems, and data mining. Those are people that might do a little bit more mathematical side of information systems. What can I do with IS? Some of the career paths, you can become an IT manager or director, database administrator, software developer, as I mentioned. Some still do software development, help desk technicians, which are very important. For example, we have some people that are working at the Chicago Mercantile Exchange, CME Group, that do major help desk work with them, and that has to be high security, and they have a lot of responsibilities. But it combines technology with business processing, allowing IS and IT professionals to help an organization improve themselves with information, is summarized. Now, the other two undergraduate, traditional undergraduate majors are CGE and CYS. The gaming, designing and implementing games, casual, serious, video, they're all types of game software with the knowledge of computer graphics, animation software, computer networking, artificial intelligence. Those are some of the areas that we've had former students work in. Testing, quality assurance, there are people that just test games, that try to break them when in their development phase. Planning and managing, again, project management and project configuration, things like that. We've had a couple of recent grads get hired by gaming companies or companies related to gaming, and one is High Voltage at Hoffman Estate. We have a student who went into design there, and another one, a computer science major who doubled, and he was a double major in computer science and gaming. He works in Elk Grove at Team Play and doing work with all of the games they produce. And what can you do with cybersecurity? Just about everything. That is a wide open field, and companies are in dire need of people who are trained in this area or educated in this area. We have a problem with trying to get people in this area, and you really have to be good in computer science and also in some cases mathematics, but you just have to have also good networking background, network engineer, cloud architect, system administrator, penetration and vulnerability tester, software developer. Even everybody that develops software has to be good and has to think about cyber security or just computer security, software security when they develop software. There are cybersecurity analysts, IT auditors, cyber crime investigators, forensics. We have a person that went through our master's program, and he worked for many years as a forensics person for cyber crime within a local city government here. So CSIS and related majors, what I want to do is just give you a feel for what kind of courses you'll take. what our curricula are designed around, how they were designed. So CSIS curricula are relevant to the software and IT industries. One of the ways of summarizing this is to say that our curricula designs are based upon a balance of theory and practice. The theory is so important, but I like this saying, I don't know who it's attributed, no one really does, but theory without practice is useless. Practice without theory is dangerous. I could spend an hour talking about what that really means. Let me try to summarize it in less than 30 seconds. I want to just say that theory without practice, sometimes in pure mathematics and so forth, sometimes you're working in that area. It's not useless. Someday it may be useful. So I don't want to just say pure computer science research is useless, but what I try to do, what we have tried to do in designing the curriculum is bring and tie the theory to what is relevant in industry now. Now, what do I mean by practice without theory is dangerous? It means that if you go out and you learn some software, you have a very narrow view of how to use a programming language, or you only know one programming language, you only know how to work with one operating system, and you don't understand the underlying concepts of operating systems or runtime environments for programming languages, you may be left behind because these fields are changing. The software and the platforms, hardware and software platforms and applications are changing all the time. Next year, it's going to be something different. And so what we try to do is build on theory, but then what we do is we update certain courses with software, with the platforms that are being used and what companies are using for testing our students to get internships. For example, just as an example, I could cite others, but some companies want you to have skills in some technology, software technology like ASP.NET. So there are some companies that will test our students to give them a little program to write and see if they could solve it or write the program. And so what we try to do is build in some of the tools that are widely used and use certain languages that are widely used in industry and build on top of the theory, tie them to the theory. And so the dangerous part is you can't just go out and practice and not really understand the big picture and the underpinnings of your subject matter, of your technology. The other thing is, a lot of people are looking and, parents and students are looking for programs that have these. I just picked these. These seem to be most asked about is, do you have data science or do you cover big data? And yes, we do. And we have courses toward that, and visualization. We have a course that has that. In our algorithms class, and I'm going to go over that, we cover using large files and the problems that one deals with in using large files. In our AI class, for the second bullet point, we deal with machine learning and all the tools and the algorithms underlying that, neural nets, and just a whole host of tools and concepts underlying that. Robotics, we don't have a specific course. We can't be everything to everyone, but we do have independent studies that students have worked and built robots. I have I have a couple of them. I'm actually doing some work in writing a little mini language for translating solutions to paths into the instructions for controlling a robot. So we do work in this. Cybersecurity, we have 5 cybersecurity courses, but it's interspersed throughout all of our courses. It's so important. Quantum computing, we are not doing anything with that just yet. That is, top, real pioneering kind of work right now. And we don't have facilities, quite frankly, for doing that. But we do have internships available at Argonne and places where they are doing this work. Computational science, I am in the process of talking with our physics professors about doing some courses to help out building, for physics majors and teaching them programming skills and techniques and so forth. That is really important now. The other thing is, I want to mention, at least our computer science, I will compare our computer science core and what we have as content to any other school, even the larger schools. We are based on the Association of Computing Machinery's curriculum guidelines. In there, there's 18 areas of knowledge. There's over 1,100 knowledge units of outcomes. You can't cover everything, and they know it. So there's tiers, and we have covered all of the tier 1, meaning the 100% that they need, and about 90% of tier 2 and many of the tier 3. What I mean by tier 1 and 2, 3 is that because there's so many outcomes, you can't cover everything, but you got to get the core outcomes. So what they're doing at Stanford, we're doing here, for example, and you can name other schools. Let me start before I even cover CS, CGE, and CYS courses. The core to me is these mathematics courses. We require Calc 1, discrete math, and then discrete math 2 is built upon discrete math, the 301, but it emphasizes using specific programming languages that help illustrate the concepts that are covered in the discrete math. Now, some of you don't know what discrete math is. Let me just summarize it as best I can right here. It is more about the logic, set theory, and some probability theory in there, and what I do in 302 is, and it's done in 301, but we really try to show how to use it for analyzing algorithms. We have to say, okay, I've got a solution, I've got this program, how can I predict whether it's going to run fast enough and without even running it on a computer? And of course, there's empirical timings and things like that, but we get into that. And then the other thing is, in discrete 2, we talk about the math that you need for neural nets and machine learning, and the math that's needed for computer graphics, things like that. And just to name a couple, if you don't know what it means, it's okay. It's linear algebra and probability theory are 2 very important key topics that are covered in there. We do strongly recommend that Calc 2 and Calc 3 be still taken, even though it's not required. Reason we don't require is because we have to accommodate some of the transfer students that can get through in 2 years. Those of you starting in freshman year, first year, we encourage you to do all of those. And then even more math. The more math you have, the more valuable you are to a lot of employers. And just to show you, here's our computer science curriculum. A lot of courses to look at. I don't want you to memorize this tonight. But CS1 and 2, that's we're using C++. We went to Java for a while. We've talked about going to Python. Whatever you study in high school, even if you don't take a programming language class in high school, we have students come in completely starting from square one in CS1. But if you do take a language, it doesn't really matter. I just do say that the AP exam is done in Java. So, but we have a lot of students that come in with Java and can adapt to C++. Why do we use C++? It's widely used still. And some of my research that I do, and I'll talk about with students, is done in, I do high performance computing and concurrency theory, and to get that performance, we really have to use C and C++. And then it also forces students to get closer to the machine, which we want. Now, we do cover Python and Java later in the curriculum among JavaScript and all the popular languages, or widely, not popular, but widely used languages. We still have computer organization and programming assembly. Why? Because part of cybersecurity is to know how the hardware is working, and some of the problems is with viruses and software and malware in general. It's down at that level, and you have to have a general understanding. And also, when you get into writing code in the higher level code, you have to understand the hardware. Object-oriented design is an important concept, and in there we cover things like mobile apps and graphical user interfaces and things, and we build on CS 1 and 2. In a way, 318 is like a CS3 class. The analysis of algorithms, that is a very theoretical course, but I tie that, when I teach that, to practical applications. For example, I'll cover things in signal processing, and I'll cover things that are algorithms in signal processing, and algorithms that are used in neural nets that are in turn used in machine learning. Computer network systems are very important. We look at specific network systems, everything from wireless, WANs, LANs, everything. Artificial intelligence, I've been talking about that. That's where machine intelligence is learned. We do look at algorithms from a different perspective in there, along with logic systems. And then 419 and 440, that's where I have those two bullets, the little asterisks there. You can take either one, but Java and web-based, those are the practical ones, the Java enterprise systems, and tying them to web systems where the students do projects in those courses that connect to databases and give user front ends. Like if you go to your doctor's office or dentist's office and you see a front end where they're putting in all information, that's the kind of things that you would do in here. Just as an example, operating systems, like Windows and Mac OS and Android and iOS and so forth, we cover all the concepts in that. And then software engineering is our capstone. I skipped over 435, I'll come back. Software engineering capstone is much like the senior paper in math. You do a major project in there. And we have students that work with outside companies. In fact, we had a really great successful team project that worked with a company just last spring. Concepts of programming languages, that's where you learn how translators are built, and again, how to work with cybersecurity issues and so on. Just to show the gaming and the CYS, I just show the core. Your first couple years at Elmhurst in our CSIS programs, you don't really have to choose your major if you're not sure your first couple years, because all the courses are the same for CGE and CS and CYS. And then you branch off. There is one course we don't cover, assembler or computer architecture for the gaming. We do have a 303, the game design, during the second year instead of 310. And then you have animation, simulation, three-dimensional game design. We usually use Unity, but we could use something else down the line. Computer graphics, and then the capstone big project courses. And then in cybersecurity, again, you can see it's almost identical to CS, except that we have these specialized computer security courses after that. You have a choice between 410 and 412. And then for information systems, you can see the math is a little different. You can either take Calc 1 or business calculus, and then you must take elementary stats, and then a business course called accounting and financial management, and one additional business course like advertising marketing. That's what I was saying earlier. IS is applied to business. And then here are the courses, and you can see it's a little bit different. We emphasize larger picture. The 315 is what the digital media is required to do, the web design and programming. We actually call it development. I forgot to change that. Anyway, that is where they get a bigger picture of software systems, and they can start looking at not so much programming, but more about the database design, database management, and the top level aspects of software development and making systems talk to each other. So what jobs do we have? Well, I just went through just the other day, just to update this. I went on LinkedIn and I got some of the places that students are working at right now just in the past 2 years. And I could go all the way back. You know, as I said, I've been here for a long time, and we've got students doing tremendous work. And there's even a father on this right now that is a former student, is outstanding and has done so much work in the area in software development and project management and everything. But we have data scientists, students who, one student went through the master's but was an undergrad here, and she just started working at Ace Hardware headquarters doing some very interesting analytics work. We got 5+ software developers there. Acuity Insurance is ranked, if you go online, you got to look these people up. This is a tremendous company to work for. They're up in Sheboygan, Wisconsin, which is about 50 minutes north of Milwaukee. But they even pay 401k for internships. They provide money for interns, and it's a joy to work there. It's one of the best places to work. It's always ranked by many job placement software companies and so forth. That, in fact, I go up and I talk to them every year. That's one of the things that we do as professors. We're very involved with industry, and I've been up there every summer for 2014, meeting with VPs about what they need from our students and what we are seeing in our students. And they are a tremendous company to work for. In fact, compared to other insurance companies, they are they like to say they're a software development company inside an insurance company. They write all their own software. They never try to have to fit together outside software that's always ever changing. AmericanEagle.com up in Des Plaines, we have actually more than 10 over the years, but right now I counted 10 that are currently working there. You've probably seen their television commercials. BMO Harris, software developer, Broadcom. It goes down the line, and we just had another student just get a job at Northrop Grumman just the other day. NSA, I'm not allowed to say what that student is doing. It's that private. So anyway, and then we have a lot of other, all the way down. There's so many to list. And just to show you, these are a little bit outdated. I did the other day go out to the Bureau of Labor Statistics, and they really don't have many updates. I think they need help in labor and updating their sites. But anyway, just this hasn't changed that much from 2020. But here you got computer occupations, 62% of the science, technology, engineering, and math. And then we have just some of the pay scales. This is sort of skewed because of other parts of the country that are a little bit higher than Chicago, but this is a pretty good indicator of where software engineering salaries are. And then game developer salaries. It's tough. I'll tell you, it's tough to get into being a game developer at first. Some of our game majors do go in internships like at web development companies to do the design and the front end of their websites for their clients. But we do have a number of students that are working in the industry, but it takes a while to get your foot in the door. And then cybersecurity, there are so many opportunities in there, and it's very lucrative, but very and very exciting. Extracurricular activities, Dr. Crawford already talked about the Associated Colleges of the Chicago area, ACCA, Computer Science Seminar Series. We're involved with that. We have a programming competition. We've hosted that the last year. We did not because of COVID. It's looking like it may not happen this year because of schools being limited and who they have on campus. So we did have up through right before the lockdown in 2020, we had from 2015 through 2020, we had the programming competition at Elmhurst 4 of those 5 years. And then the Global Game Jam is at the end of every January. The students stay in for 48 hours and just develop a game at 5 p.m. on a Friday until 5 p.m. Sunday. We lock them in our Daniels Hall building, and we have English majors, computer science majors, music majors, art majors, everybody working on games. And there's a theme that's released by some international entity. And then we have Game Developers Club. We also have a Software Engineering Developers Club that meets on Tuesdays and Thursdays, and they just solve problems, and they pretend like they're doing a job interview and have to present a solution to a problem. We have game nights in the library. We do have an esports team. And then there's summer research, which I'll talk about right now. For example, one of my star students was Kevin Prennan. We worked on something. He did an independent study over a couple of years, and we ended up getting a paper accepted at an international computer vision conference, which was pretty prestigious, and he did some great work. And I'm carrying on with the work, and he's in industry now. And then we have some other things that Dr. Brown, another one of our professors who works with this, he had a student, Ben Bollinger, worked on some encryption and some software with the Oculus system. And then Internet of Things, Dr. Jensen is working with Nathaniel Jones, who just graduated. And finally, are there any questions? I just made it.
I just want to thank Dr. Jeffrey and Dr. Crawford so much for taking the time to join us today and share about the Department of Computer Science and Information Systems and the Department of Mathematics. It was amazing. It was super interesting and informative. I definitely learned a lot that I did not know before. So thank you so much. And I hope everyone had a chance to get their questions answered, learn a little bit more about your program of interest, and learn a little bit more about Elmhurst and what we have to offer. Like I said, feel free to reach out to the Office of Admission or me personally, any questions about Elmhurst or the admissions process, and then to Dr. Jeffrey and Dr. Crawford as well about everything they spoke about tonight. We're so happy you can join us. Have a great rest of your night, and we hope to keep in touch and hear from you all soon.